Hello, I am Dr. K.S. Badarinarayan, the Principal of MS Engineering College. I invite you for a discussion on optimal solution to transportation problem using UV method. Here, I consider a small problem for explanation purpose, wherein I have got only 4 warehouses and 4 destinations with the availability and the requirements and the cost of transportation as shown in the matrix. I am also going to use the northwest corner method for getting the basic feasible solution. So, the northwest corner method, I am not going to consider the minimum cost. Irrespective of the cost, I am going to select only the northwest corner as my allotment. So, in the first phase, from W1 to D1, I have got the northwest corner cell where the items has to be transported from W1 to D1. So, the availability here is the 5 units, but the requirement is 10 units. So, hence we can allot 5 units from W1 to D1. So, in that particular process, I'll be able to allot 5 units from W1 to D1, and thus the availability at W1 is exhausted and the requirement at D1 gets reduced by another 5 units. And by that process, I am also going to cancel the W1 row. The next northwest corner cell is W2 D1. So, wherein the availability is 7 units and the requirement is another 5 units. So, I can transport another 5 units from W2 to D1. So, by doing so, the requirement at D1 is completely satisfied and the availability at W2 gets reduced to 2. So, I am going to cancel the column D1. The next northwest corner cell we have is W2 D2, wherein the availability is 2 units and the requirement is 5 units. So, we make an assignment of 2 units from W2 to D2. Now, here the availability at W2 is 7. So, therefore, the availability at D2 is satisfied. So, we are going to cancel the W2 row and reduce the requirement at D2 to another 3 units. The next northwest corner cell is W3 D2, where we have the availability of 8 units and we have a requirement of 3 units. So, that we are going to satisfy by transporting from W3 to D2 another 3 units. So, after transporting 3 units there, the availability at W3 gets reduced to 5 units and the total requirement at D2 is satisfied. Therefore, we cancel D2 column. The next northwest corner cell is W3 D3. So, for which again you will have an availability of 5 units and requirements you have 10 units. Therefore, we transport from W3 to D3 another 5 units and we see that the availability at W3 is satisfied. Therefore, we cancel W3 row and also reduce the requirement at D3 to 5. So, thus we cancel the W3 row also. The next northwest corner cell is W4 D3. So, wherein we have 10 units availability and the requirement of 5 units. Therefore, we transfer from W2 to D3 5 units. Thus, now the total requirement at D3 is satisfied and availability at W4 remains as 5. So, the last northwest corner cell or for the entire matrix will be W4 D4. Thus, we are going to now transport from W4 to D4 another 5 units and that will be the end of the northwest corner method. So, wherein if you look at, we have got the number of rows 4, the number of columns is 4 and the number of cells allotted is equal to 7. So number of rows plus number of columns minus 1 is equal to 7, that is equal to the number of assignments. So hence we get a basic feasible solution using northwest corner method. Now from this basic feasible solution, we move on to UV method for finding out the optimal solution. So here we have got two types of cells. One is basic cells, another is non-basic cells. So the basic cells are the one where we have got the allotments are made, and the non-basic cells are the one where the allotments are not made. So in this particular matrix, if you look at in this particular matrix, the W1 D1, we have an allotment, therefore it's called a basic cell. W1 D2, there is no allotment, and that's called a non-basic cell. So for the basic cells, the relationship Cij is equal to Ui plus Vj will hold good. For the non-basic cells, we calculate the net evaluations Cij is equal to Ui plus Vj, and we compute all the net evaluations. If the net evaluations are all positive, that is greater than or equal to 0, then we say that we have got an optimal solution. So in this, we also have to calculate now the different u's and v's, u for rows and v for columns. So since we have 4 rows, we determine, or rather we compute u1, u2, u3, u4 for the rows, and for the column variables are defined v1, v2, v3 and v4. Using the relationship, we just find out Cij is equal to Ui plus Vj. That means if we take the first value C11, so it will be C11 is equal to U1 plus V1. That is 6 is equal to U1 plus V1. Suppose if we take U1 is equal to 0, now what will happen is V1 is equal to 6, and that's what we'll be in a position to note that is the value. So the next, for the cell W2 to D1, we also compute that 7 is equal to U2 plus V1. That means here again we calculate what is the value of U2. So the U2 turns out to be 1. So similarly, for all the rows and for the columns, we determine U's and V's in the same procedure. So U3 becomes minus 3, V3 becomes 19, and U4 becomes minus 9, and V4 becomes 11. So now for the non-basic cells, we compute the net evaluations. The net evaluations are nothing but Cij minus of Ui plus Vj. So for the first non-basic cell, that is W1 D2, we calculate, that is the first C12. C12 means the first row, second column. So C12 is like 7. 7 minus of U1 plus V2. So that is 7 minus of 0 plus 8 is equal to minus 1. So similarly we calculate for W1 D3 the net evaluation, that turns out to be minus 16. And if you look at the entire matrix for W2 to D3, we have calculated the net evaluations turns out to be minus 19. So in the entire matrix we take the highest net evaluation, that is most negative net evaluation, and we consider that particular cell to enter into the basis. So the arrangement of the items transported takes place, and that particular reconfiguration of the entire matrix is what we are going to learn now. So we consider that W2 to D3 will have some additional units it's going to get. So when we get some additional units there, that means if you are adding any value to W2 D3, the same number of units has to be subtracted from the next cell, that is connecting cell W3 D3. If you are subtracting any value to W3 D3, again you have to add something to W3 D2. Suppose if you are subtracting anything to W3 D2, you have to add, rather subtract something to W2 D2. That means plus minus this process goes on. So now if you look at the negative cells, that is you have 2 and 5, amongst that the minimum is 2 and 5. So we take theta is equal to 2. That means what we are going to do here is that this 2 will be added, and 2 will be subtracted in this particular matrix. So in that particular process, what's going to happen is that the rearrangement of the cells happens, and this is the new matrix we will get. For the again new matrix, what we are going to get, we also find out the u's and v's. That means we recompute the u's and v's, and for which the same hold good, the same equations holds good, that is Cij is equal to ui plus vj. Now once we calculate this u's and v's, we also calculate the net evaluations Cij minus of ui plus vj. The same way what we are going to calculate the net evaluations made are depicted like this. So if you look at now again here, we find some W3 D1, it is minus 16, that is the most negative one. So therefore that particular cell W3 D1 needs to be added some values. So if you are adding again there will be a disruption of the values that are of the units that are going to be transported. So what is that particular cells that has to be added and subtracted, we have to check. Now we are going to make again another loop in which whatever that you are going to add in W3 D1 has to be subtracted in W2 D1, and it has to be again added in W2 D3 cell, and again it has to be subtracted in W3 D3 cell. The same loop we have to maintain. So that means in the minimum, that is between 3 and 5, we take the 3 units and then we add and subtract 3 units. So the resulting matrix will be as shown. Now for the again this matrix, we calculate what are the u's and v's again. That is u's and v's are determined. Again for the non-basic cells, the net evaluations are calculated, and it is found that for W4 D2 the net evaluations are minus 6. That means again this particular cell we are going to add some value. If you are adding that some value there, again it changes the structure of the matrix. So what is the structure is going to change? That means how it's going to be connected. So if you are adding in W4 D2, you have to subtract something in some value in W3 D2, and then add some value in W3 D1, again subtract in W2 D1, again add something in W2 D3, again subtract in W4 D3. So like that the entire loop happens, and the value that's going to be added and subtracted here will be equal to 2. So the 2 is added and 2 is subtracted from all the remaining cells. By doing so, again we get the rearrangement of the entire matrix like this. Again we calculate the u's and v's as usual for all the basic cells, and for the non-basic cells again we recompute the net evaluations. Now we find that there are the W1 D3, again we have minus 3 as the net evaluation. That means to say again we will have one more round of the loop formations. That means if you are adding W1 D3, again it has to be subtracted in the connected nodes as we have explained earlier. So when we make additions of 3 and then subtractions of 3, again the resultant matrix will be as shown. The resultant matrix again, for which we are going to calculate u's and v's using the relationship, same relationship C1 Cij is equal to ui plus vj. Again for non-basic cells we compute Cij minus of ui plus vj. So we find that in the entire matrix all the net evaluations are positive. That means when you have reached all the net evaluations positive, we say that we have got an optimal solution. When we get an optimal solution, what we do is we just calculate the optimal cost also, which is going to be for the first cell it is 2 units, into 6 is the cost of transportation per unit, so it will be 2 into 6. For the next W1 to D3, it is 3 units into 3 rupees, so 9. For W2 to D3, it is 7 into 1. W3 to D1 is 8 into 6. W3 to D2 is alpha into 5. W4 to D2 is 5 into 9. W4 to D4 is 5 into 2. So the same values are recorded in this particular matrix or table. So we find that the total cost of transportation is 131 units. I hope you have understood. Thank you for watching. Please subscribe to MSEC's channel.